Welcome to the lecture. Today we are going to discuss replacement second model. In first model, we replace the model. It means we replace the mission without cost, with considering we are considering. Here, coming to this replacement policy, here those who running cost increases with the time, but value of money changes with constant rate during a period. Here, compared to the previous one, here we are changing the money value. Here we are changing the money value. It means, suppose for example, if we take the bank, there they are giving the rate of interest for annum, per month, for some duration they are given, some FDs they are providing. For that they are giving some rate of money value they are given, interest rate they are given. Likewise, here also we have taken the money value for replacing the item. Here, for example, if we take the value is 100 rupees, then the spent after 1 year it will increase 1 year. It means we are increasing the 10% money value we are increasing here. Okay, and here the value of money that decreases with the constant rate is known as depreciation ratio or discounted factor. Here we are calculating depreciation ratio and discounted factor. Based on this discounted factor, we are going to replace the mission or we are going to replace the item. Here this discounted value is the amount of money required to build up funds at compound interest that is sufficient to pay the required cost when due. Okay, example we have taken the bank. Suppose if we take the loan or we are going to deposit the money, they tell us some of the years your interest rate will be increased from 10% or 12% or 13%. Likewise, here also we have the rate of interest. Here also we have the discounting factor we have. We are going to calculate the discounting factor based on the percentage of year. Here we are going to take the percentage of year is R we are taken, and here we are taken n number of years. So the formula is we are going to calculate depreciation rate or discounted factor. We are going to calculate by the help of 100 by 100 plus R into N. Here, what is our interest rate? Interest rate R and N is number of years we have taken. Okay, here B is the depreciation value or discounted rate. Okay, after calculating the depreciation value, we need to determine the critical age. It means critical age means we are going to find the annual cost and the cumulative annual cost we are going to find. After that, we are going to take the replacement year. It means gradually it will be decreased. At some years, at some age, it will be increased. When we are having the lowest value, there we are going to replace the item. Like here also, likewise, we are going to replace the item. Next, coming to the example, here I would like to explain this model with an example. That is, let the value of the money be assumed to be 10% per year. Okay, to be 10% per year, and suppose that mission A is replaced after every 3 years, whereas mission B is replaced every 6 years. Okay, here we are going to replace mission A is every 3 years and mission B is every 6 years we are going to replace. The yearly cost of both the missions are given as follows. Here they are given the years, number of years, 6 years are they are given. Then mission A costs they are given. Then mission B cost they are given, and they ask to determine which mission should be purchased. Okay, here in our market we have two types of missions, that is mission A and mission B we have, and there they are given the money value, 10% of money value is given, and mission A is replaced after every 3 years and mission B is replaced after every 6 years. They are given predetermined their age. The mission age also they determined. Okay, they are given. Okay, then solution. Now we are going to find the discounted cost. It is also called as present worth. Okay, here the presented cost, present worth or discounted cost is they are given in our problem is 10% they are given. Okay, based on that we are going to calculate the age factor based on this table. Okay, here for mission A I would like to calculate first mission A. This is I am going to calculate mission A. Here the mission A years are given 1, 2, 3, and the cost of mission A is 1200 400, 1000, 200, 400. Okay, they are given. Next mission B is 1700, 100, 200, 300, 400, 500. They are given. Now coming to the mission A, the cost here why we are taken 3 years means they are given in our problem. Every 3 years mission A is replaced. Okay, here our table also we have like that only. Every 3 years the cost will be changed. Initial cost will started every 3 years. Okay, the cost is 1000, 200, 400. Okay, and coming to the discounted cost at 10% rate of interest. Here we are going to calculate the discounted cost. Here they are given, let the value of the money be assumed to be 10% per year, and suppose that the mission A is replaced after every 3 years. Here we have to remind one thing. At initial stage, at first year we don't have any interest rate. We don't calculate any interest rate. First year means simply we are taking 1000 into 1. So first year we are going to take 1000 into 1 directly we are taken. There is no discount rate. Okay, it is directly present for this 1000 rupees. Next coming to the second year, here the cost value they are given, mission cost is 200 they are given, and we are going to calculate the discount cost at 10% rate. We have the formula discount cost, depreciation cost we are going to calculate by using the formula is 100 by 100 plus R over N. Here what is the D? Here we are going to calculate the D by the help of cost value. Here we have the cost value. So 200 into D we are going to calculate. This is called as present worth value. 200 into D. From this 200 into D. What is the D value? D is formula we have 100 by 100 plus R. What is the R value? R is the percentage of year. 10% they are given. Discount cost 10% we are taken 10 power. What we are taken? Years. Number of years. It means it is first year we are going to calculate. I mean for coming to this first time we are going to add this work factor. So simply we take power 1. So from this we are going to get 200 into 0.9091. Okay, after this we get 181.82 rupees. Next coming to the another one, third next year. What is the next year? Next year value is 400 is there. So same I take 400 and 100 by 100 plus 10. 100 by 100 plus 10 we are taken power square. And second time we are going to take the percentage of worth discounted cost we are going to take here second year. So simply we are going to take second. Okay, it is not belongs to this year. It is belongs to when how many times we are going to add that present worth factor. Which year we are going to add that worth factor. Okay, at first initially we don't add any worth factor. Next coming to the second one we are going to add one worth factor. So we are taking n is 1. Here n is we are taking 2. Okay, this is for mission A. Then the total cost is replacement cost is total 1500 1240. Okay, next coming to the mission B. Okay, here from A we get thus the average yearly cost of mission A is 15 12 40 by 3. So 504 rupees we are going to expand every year. We are expanding expenditure. We have the every year expenditure is 504 rupees for mission A. Next coming to the mission B calculation. If the problem itself they are given the 6 years. 6 years means here we are taking 1, 2, 3, 4 years. Every year we have the cost value 1700, 100, 200, 300, 400, 500. Let's say 1700 into 1, 100 into 10 by 11 we are taken. Here how we get the 11 by 10? This is a D value. D, what is the formula we know? D is equal to 100 by 100 plus R power N. Here R means discount cost. Discount cost means 10%. So 10% we are taken. 100 by 100 plus R we are taken. It means how we get the 10 by 11? From this we are going to get 100 by 100 plus 10. That implies 100 by 110. So simply we remove that 0. 100 times we are we are dividing that one. So finally we get 10 by 11. So same for second year, third year, 2, 3, 4, 5, like this. After this we are going to get 100 into 0.901, 100 into 0.8264, 100 into 0.7513, 0.6830, 0.6209. Okay. Finally we get the total value is rupees 2765.23. Next, here from this average yearly cost of machine B is how many years we are going to calculate this? 6 years. So the average cost is 2765.23 by 6 is equal to 460.87. Every year we are going to expand 460.87 rupees. Okay. From this, with the data on average yearly cost of both the machines, the apparent advantage is in purchasing machine B. Because at machine A we have the highest value, cost value 504.13, but here machine A we have less value for 460.87. So, but the periods for which the costs are considered are different. Okay, therefore let us first calculate the total present worth of machine A for 6 years. Here, previously we calculated only 3 years for machine A because as per the norms they are given 3 years only. But here I am going to calculate 6 years work factor. For total 6 years I am going to calculate. At the cost of the initial we have 1000 into 1 we are taken. Second year 200 into 100 by 100 plus R value we are taken. Power 1. Here 400 third year. Same, power 2, 1000, power 3, here 200, power 4, 400, power 5 we are taken. It means the cost values are like this. For A I am calculating. Suppose for coming to the first year. First year is we have 1000. So 1000 into 1 we are taken. Next second year, 200 is there. For this 200, we are going to add the worth factor 100 by 100 plus R power n. Next third year, 400 into 100 by 100 plus R power n. Like that, we are going to calculate 6 years. After 6 years, we get this 2648.64. From this, we are going to calculate present work factor of machine A is, if we consider 6 years, machine A is better compared to machine B. Because here the machine A we have 2648.64. Coming to the machine B we have 2765.23. This is the present work factor. Okay. From this we are going to choose machine A is the better. If suppose we consider 3 years of cost values, we considered 3 years of present work factor we taken into the we considered. From that we are going to replace machine B. Okay, but if suppose if we go for 6 years, we are going to replace. We are going to purchase machine A. Okay, because here the cost is present work factor is low compared to machine B. Okay. Next, coming to the another example. Here a pipeline is due for repairs. The repair would cost rupees 10,000 and would last for 3 years. Alternatively, a new pipeline can be laid at a cost of 30,000, which would for 10 years, assuming the capital cost to be 10% and ignoring salvage value. Which alternative should be chosen? Here they are given the pipeline repair due date. They are given after some age we are going to replace the pipeline. Okay, here they are given the repair cost is 10,000. They are given and for the last for 3 years they are given, and already a new pipeline can be laid at a cost of 30,000. Okay, here the if we taken 3 years of maintenance cost, that will be 10,000. Okay, Suppose coming to the new pipeline, we are going to replace the existing one. We will with the worth of 30,000 rupees only we get the new pipeline, and 10 years there is no maintenance. Okay, for the 10 years factor we have 30,000 rupees only. But coming to this old one, every 3 years we are going to expand 10,000 rupees. Okay, if suppose coming to the 10 years, it means it may exceed. Okay, around 35,000 it will be take. So here we are going to replace, or we are going to calculate the repair cost or present work factor or year of which year we are going to replace. Those are we are going to calculate here. Coming to the solution, here we have the two types of pipelines. One is the existing one, and another one is the new pipeline. Next here, they didn't give any replacement year. They didn't give. Just they are given the period of time and the repair cost for years they are given. Okay, for 10 years they are given at a new pipeline case, and 3 years they are given at a existing pipeline case. Okay, so after this we are going to take the discount rate. In our problem they are given the discount rate is 10% they are given. Okay, the present worth factor of the money is 10% they are given. Here we know how we calculate the 10% depreciation cost. How we calculate D is equal to 100 by 100 plus R power n. Here initially we don't take any value, so D is equal to 100 by 100 plus 10. This is the depreciation cost. From this we are going to get 0.9091. This is our depreciation cost value. Okay, next. Here now we are going to calculate the discount value for all further costs associated with the policy of replacing the equipment after n years. Here we don't know the years. Replacing years they didn't give. They given only existing one pipeline maintenance cost and new pipeline maintenance cost they are given. From that we are going to find the number of years we are going to find. Okay, by the formula, by help of the formula is dn is equal to c plus c into d power n plus c into d power 2n. Here we know the d value. D is depreciation cost or work factor. Okay. Next, here c is the initial cost. From this, they simplified the formula is c into d power n plus d power 2n plus and so on. It is equal to c by 1 minus d power n. Here it is for infinity case we are going to take that one. Here what is the c value? C is the capital cost and d is the depreciation cost. Okay, depreciation cost we are going to calculate by the help of this formula. D is equal to 100 by 100 plus r power n. Okay, here we are going to substitute c value. After substituting c value, we are going to get the years. Okay, coming to our example. Here, what is the c value they are given? They are given c value is two c values are there. First one is 10,000 for existing, and second one is 30,000 for new pipeline. Okay, first we are going to take the initial one, d of n. Here we are taking d of n is existing one. Existing d of n is they are given n is equal to 3 years. They are given 3 years. They are given. So that's why I am taking d3. And the capital cost c is equal to from this formula. Here we don't know the years, total years, replacement years we don't know. So simply I would like it is infinity case. So c by 1 power d power minus n we are taken. Here c value is capital cost. For 3 years they are given 10,000. 10,000 by 1 minus 0.9091 power 3. Okay, this is for third 3 years. So we get rupees 1421 approximately for existing pipeline. Next, coming to the new pipeline, they are given 10 years maintenance cost. 10 years initial cost they are given. D10 equal to 30,000 by 1 minus 0.9091 power 10. How we get this 0.9091? This is a depreciation cost. Depreciation cost we get D is equal to 100 by 100 plus R power n. From this we get this one. Okay, depreciation cost. Here m is equal to, we take 1 initially. Okay, after this here D3 is less than D10. So the existing pipeline should be continued. Alternatively, the comparison may be made over 3 into 10, that is equal to 30 years. Okay. Here up to 30 years we calculated. The existing pipeline may give the life is 30 years they are going to give. From this we are going to calculate the existing pipeline we are going to replace after 30 years. What we learn from this problem? Here from this problem we are going to replace the pipeline. For example, a government they call tenders for supplying the waters or for building the canals. They call the tenders, and they give the some duration. They give after that for that duration only they invite the bids. The bidders they bid their quotations based on this type of examples. This type of periods they are taken. Government they considered lifespan is 100 years or 150 years. Based on that they invite the quotes. Then bidders they think over that years and they implement the plans. Okay, already they choose in market we have many number of pipelines are available, and similarly new designs or existing designs they consider. Based on that they are going to replace the pipeline or they are going to choose the design. Okay, and they satisfy the government needs. Here in our problem also we have the initial cost is 10,000, and after we have new pipeline is 30,000 for 10 years. From this we are going to identify and we finalize the existing one is the best one. It will be suitable for remaining 30 years. Okay. Next, another one, present worth factor criterion. Here in this case we are going to calculate the optimal replacement age. Optimal replacement year we are going to calculate. Okay. Here we are using two situations. Coming to the first situation, the running cost of an equipment that deteriorates over a period of time increases, and the value of the money decreases with a constant rate. Okay, if R is the interest rate, then present worth factor we have taken PWF equal to PWF means present worth factor. Present worth factor is equal to 1 plus R power minus N. Here R is the interest rate and N is the number of years. Okay. Here decreases with the constant rate. If suppose they are going to decrease, first year they are given 10%, and then the second year they are going to decrease 15%. Discount they are going to give. Okay. In our social sites, in our commercial e-commerce sites also they offered items like 15% discount sale, 20% discount sale, like that they are going to offer. Here also mission wise also we are going to calculate the discount rate, and present worth factor we are going to calculate this. Okay, PWF equal to 1 plus R power minus N. Here R is what is our constant rate, and N is equal to years, number of years we have taken. Okay, and here we are going to actually it is also called as present worth factor. D is equal to 1 plus R power minus 1. In previous case, what is the D value? D is equal to 100 by 100 plus R power N we have taken. Okay, there the interest rate is constant, but here the constant interest rate with the decrease. Constantly it will decrease. Okay, money is decreased with interest rate. The capital cost is there we have the capital cost is constant, but here the capital cost also decreased based on the interest rate. Okay. Next, second one, the money to be spent is taken on loan for a certain period at a given rate under the condition of repayment in installments. The replacement of items on the basis of present worth factor includes the present worth of all future expenditure and revenues for each replacement alternatives. An item for which the present worth factor is less is preferred. Let C is equal to purchase cost of an item, and R is equal to running annual cost, and N is equal to life of the item in years, and then small r equal to annual interest rate, and S equal to scrap value. Here we are going to calculate the present work factor for total cost is equal to C plus R minus S. Okay, here we are taking R is annual running cost. This annual running cost was varied with money interest rate. Okay, here suppose annual cost is, if suppose first year we have 1,000 rupees, then it will be gradually decreased with rate of interest. Okay, with rate of interest. If suppose if we take the 10% interest rate, after 1 year it will be decreased with the rate of 10% interest. Then after, if suppose if here we get the 900 rupees, then next year it may be decreased 10%. It means the annual cost is 800. Like that we are going to decrease every year 10%. Okay, from this we are going to calculate the total cost is C is equal to C plus R minus S. Here from this we are going to calculate the work factor. Okay, next, if the running cost of the item is different for its optimal operational life, the present work factor is calculated based on the years. That is, C is equal to total cost C is equal to R plus R minus S. Here, in this case, we are going to change the running cost value as well as scrap value or salvage value. We are going to replace. Previous case, what we replace? We replace only cost value with constant interest rate. But here, the running value and scrap value both are decreasing based on the interest rate. Okay, for this case, we are going to calculate the replacement years or replacement period by the help of present work factor. The present work factor we calculated from the formula is capital cost plus running cost minus salvage cost. These running cost and scrap values are varied with help of interest rate. It is a good example for money bank examples.